All right, now that we turn the shoulder to length, okay, so we got our diameter, we have our shoulder to length here. We're going to go ahead and move this out of the way. We're not going to need this for a few moments, and we're going to put the chamfer on the end of the part. Now, the chamfer that I've referred to is this one here. You can see it in either direction, but essentially it is 062 by 45. That means it's 45 degrees, okay? And that also means that it needs to be 062 this way and this way. All right. In order to achieve that, we need to create an axis of movement in that angle. So if our part is sitting here like this, okay, and we have a way here to go this way, and we have the x-axis to go this way, then we can simply just take our compound here and turn it around to 45 degrees so that we can achieve this. Let's do that now. We're going to loosen up the compound here. Shouldn't be terribly tight, not tight enough, not loose enough that it'll move, but tight enough that not so tight that it tears anything up when you're trying to tighten up the nuts. So we've moved it around to 45 degrees. Now 45 degrees can be indicated on this side over here, or actually if it's hard to see from the camera angle, but there's a mark here. Suffice to say that I have this here in the angle appropriate to cut that, and it is lined up on the 45 degrees. So I'm going to snug this back down, okay, and then we have to set our tool back up. Now, we're not going to go through the same process of setting the tool, but we're going to go through a similar process. We're going to crack this loose, we're going to swing it around, and the thing that is important to note is that you can use the sides here, the straight cuts, and kind of line up the tool kind of close. If it's okay if it's tipped a little bit forward. The big thing is this tip needs to contact this first. If not, if you go to contact over here, you're going to cut at this angle. So you got to get the tip out there. So even if you tip that out a little farther, it's really okay. We're not going to line it up for this really short feature that we're going to do here. So I've snugged it up and I got it in a real good location. We're going to roll this thing all the way forward here. It's going to take a minute. We're going to get it forward. And we're going to do this similar deal to where we're going to touch off. Now very gently we're going to roll up, just touch again. Okay, now we've touched it twice, we know we're good. We're going to go Z0. So from here we're going to back this out, and remember we had 062, right? So you kind of can't see it on this view here, but I'm looking at my Z-axis right up here on the DRO, and I'm going to take the Z and I'm going to roll it over to 062. I'm going to turn the lathe on. It's going to get a little noisy. I'll turn it on and I'm going to touch. And as soon as I touch, I'm going to stop right there and I'm going to use the cross slide. All right, I can see I touched here. I can see a wisp of material come off along with seeing a little line. And now I'm simply going to back this compound up just like so. All right, and there you have it. We have a 62 thousandths chamfer. All right, so if one were to want to check this just to make sure that they had it right, there's a few different ways to be able to do it. One of which isn't very easy, and that is trying to take a measurement like this. You don't have solid surfaces for this to go up against. However, what you can do is you can do a little bit of quick mental math. All right, so I have a 1/2 inch diameter, and I got an 062 chamfer that goes this way 062 and this way 062. So, all right, 62 and 62 is about 125. So that means that the diameter right here at the bottom, or at the bottom of the taper, should be about 0.375. Okay, so if I take this and I set it for 375, this should be darn close to this, and it matches up very nicely. So that means that I did my job right. All right, there you have it. That's the chamfer.